Hello, everyone. This is Abebe Gabramariam, and I'm a graduate student by the major of cybersecurity at CMO University. And this is my last semester. As my last semester, I'm presenting my graduate project. It is based on the final lab project on the TY 510. So this is HTTPS, TPS, and ASP 8266 web server. How we'll implement and how it works with each other, we'll see. So when we come to our lab contains these instruments. So we have application, we have these devices. This is ESCP 8266. Then we will upload the code here, right here. Then we have the laptop, we have projects, we have build, we have application and ellipse. All those are here. And when we go to the introduction part, we have ESCP 8266 EX. So this is nothing but is integrated Wi-Fi. So we will use to connect the networking environments by the use of Wi-Fi. So this helps us to support the other devices or applications, how they will run. Then we have the web server libraries within ASCP 8266 SDK. We have this one, this application. This is unsecured one, and this is the more secured one. That's the different. We add secure, that means it becomes more secure. So when we come to our primarily goal, this is our primarily goal, how we run this codes or by the use of code or Arduino code to get light on, off, three of them, green, blue, and red, green, blue, and this how they will work. We'll see through the HTTPS and a web server. So when we come here, as I mentioned earlier, we have these goals. These are request IDs. We have this request ID parameters from R02 up to R07. Then this is our title. We have to generate secure keys, and these are the description, what looks like secure keys. And we have HTTPS server. We will make it embedded, or it is protected or not, the private key, or all things. We will see those things, what will happen after we run our codes. So we create this request ID, then with full description, then we'll see how it works. When we come to the implementation part, we see our goal. Our goal is to see what product we'll get after we run this by the code, by the use of HTTPS and ESP 8266. So, and when we come to our implement, how we will implement it by the key generation. So we have OpenSSL command. We'll go to through the command, then we request a new key RSA. RSA is nothing. It is private key, and we use this one to transform data securities, or just we use this one for the secure data transformation. So now when we come to continue the implementation, we have source codes. We have, as I mentioned, we have this one, and we have in that one we connect the red, green, and the blue light emitting diode. We have to make it on off. So we have here functionality, HTML page. We have show home page, and we have lead means light emitting diode, red we make it high means we will make it on. We make it low means we make it L means we will make it off. So then we have HTTPS implementation here too. So how it works, this one and this one, we will see by the use of these all things. Then when we come to our first code, just as I mentioned earlier, we have this. Then after that, when we run our product, our code, we will get this product. We will see this all things as a video. Then we click here to make it off, on to make it on. Then our program is running and our code is also working properly as I show you. Then we have to go to the another thing. We set up this request ID. Then we will see by the key generation, that we generate key, we will see what looks like that. It looks like this one. We get these results after we run our demo first. So still we have some security issues because we have to make sure this becomes safe. So we will have to improve then our programs, and we have to replace HTTPS by this Negosign. This is Negosign is nothing but the reverse proxy. So, and that we are replacing this one is to get the big size RSA. So for our key. So because when we run this program by the use of HTTPS, we get some crashes when we run the program. So that's why the crash was when we use the HTTPS, our RSA key size was only accepting until 2048. So we are replacing that one by this one because this one accepts until 4096 key sizes of RSA. So then as we see this one, this is the improvement with the use of this, and with the use of this, we can run this, and we get the modules. So here also we get module, but it is only accepting until this one. When we continue by the increasing the key size, we will crash after 2048. So that's why we replace this one to make it more secure and to generate securing private key. We generate securing private key by the use of this, and after we generate secure private key, we will see our second demo. Our second demo looks like this, and it needs advanced improvement. Then after that, our program will run, because now we get authenticated certificate because by the use of private key generation, we generate private key. So this looks like this. Then when we come to summary, this as I mentioned earlier, we use these two things, and we using of this, making more key to RSA key sizes, and this is smaller RSA key size. So this looks like this. Thank you for our times.